Hello, we are going to start Unit 3 review of linear relationships. Your review should look similar to this. It all depends on what teacher you have. The only difference that you'll have is maybe the personalization within the question. Maybe it'll say your teacher's name. So here we go. So I'm just going to use one of the teachers, but all the questions are pretty much the same other than the name. So starting with number 1. It says a Netflix plan costs $15 per month, where X represents the number of months and Y represents the total cost. Fill in the table using at least 3 pairs of values. So the first thing I want to look at on this, what we're going to be asked to do is we're going to fill in the table, we have to come up with an equation, and then we have to graph it, all for this one problem. So what we're going to do is I'm going to start with coming up with my equation. It says write the equation that represents the total cost of Netflix for X number of months. So if it costs $15 per month to have a subscription to Netflix, it's going to be 15 times the number of months, so 15x, and where Y equals the total number of dollars, the total cost. So there's our equation. So using that, we can fill in our chart. It says use 3 pairs of values. So I'm just going to use at least 3 pairs of values. I'm just going to say 1, 2, 3, and 4. So if we did that, our equation was, well, it costs $15 a month. So 15 after the first month, 1 month of it will equal 15. So our total cost is 15. We had 15 times 2 months will equal 30. We want to know the total cost in 3 months. So it's going to be 15 times our 3 equals 45. And our last one, 15 times 4 months equals 60. So you can pick any numbers you wanted here. You're just going to take 15 times the number that you chose for X. Moving down to graph this. So what it says, graph this relationship below. Be sure to label both axes and scale them so that you can see how much it would cost for 24 months of service. 24 months is 2 years worth of service. So what I'm going to do, I'm going to start with my labels. So we're going to have months on our y-axis, and then we have total cost for our months for our x-axis, and total cost for our y-axis. So we're just going to plot my points. So what we need to do is put our scale factors. So we need a total of over 24 months, so 2 years. So I'm going to count each line as going up by 2s. And 24 will bring us right to that. And then, if you can see on our chart here, we're going up by 15s. So to make this easy, I want to have each line represent 20. You could go by 15s if you wanted. Yeah, why don't I do that? So it's 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, and 180. So going up by 15s. So if we're just going to plot our points that we selected, so our x was 1, so over 1, and up 15. So our first one's going to be right about here. And I'm going to zoom in. Now I'm taking everything from our chart from above, from this point. Here's our x and y values for each one. 230, 345, and 460. That's where I'm getting everything from. So I'm going to scroll down to here. It was at 230, so over 2 up 30, up to 345, 345, and 460. There's our points that we had. You can take a ruler, and we got to know that at 0 months it's going to cost 0. So you're going to go through starting at 0. So it's going to go right here. All right. So explain how you know the graph shows a proportional relationship. You can say the line goes through the origin. 0, 0. If it didn't go through the origin, it would not be proportional. That's the one rule, or that's a rule that we have to remember if it's proportional. Moving to the next page. So on number 2, it's asking you to compare 3 different runners. It says 3 runners are training for a marathon. One day they all ran about 10 miles, each at their own constant speed. So the first one's giving us our information using a graph, second one's giving us an equation, and the third one's giving us a table. So what we have to do is figure out how fast each of the runners are, and then the last question here is they want to know which of the 3 runners was fastest, and how do we know? So if we were looking at this, looking at our table, what we're going to do is, we see it, so at the very start, so at 0 minutes, 0 seconds, they're at 0. So it's a proportional relationship. I want to follow this line until it exactly intersects at a grid point, a grid line, right here. So it's telling us it takes us 20 minutes to run 2 miles. So we're running 2 miles in 20 minutes. So we want to make that more helpful. I want to know how long it'll take us to be one mile. How fast can we do 1 mile? So what I'm going to do is I'm going to reduce that. I'm going to divide by 2, the top and bottom. 2 divided by 2 is 1, so 1 mile. And 20 divided by 2 is 10. So this runner is running a 10-minute mile. So 10 minutes per mile, per 1 mile. All right, so there's runner number 1. Using this, moving on to number 2, runner 2. So we have T, which is time. And we have 6.75 times D, which is distance, or miles. This is miles. So we're going to use this. So I want to know how fast I can run in 1 mile. So T equals 6.75 times 1, because I want to know 1 mile. You can put any number there, but it's easier math if you just put 1. 1 times 6.75, so it's going to be time will equal 6.75. 1 times 6.75 is 6.75. So we have to ask ourselves, it's 6 minutes, but we have to ask, well, what is 0.75 in time-wise? 3/4 is another. What's 3/4 of an hour? Would be 45 seconds. So 6 minutes, 45 seconds is runner number 2. So runner 1, we are at 10 minutes. And runner 2, we're at 6 minutes, 45 seconds. So right now, runner 2 is much faster than runner 1. Moving on to number 3, or runner 3, looking at our chart. So we have X in distance, Y in time, minutes. And what we're doing down here, we're going to have our Y minutes over our miles. So this would be time over miles. So if we're looking at this, I'm looking at my first ordered pair here. Time was 14, so put 14 over. Distance was 2. So what's 14 divided by 2? So 7-minute miles. 7 minutes per 1 mile. So we have our 3 times now. And we can see that the fastest time was runner 2 at 6 minutes 45 seconds. So which one's faster? Runner 2 ran at, I'll zoom in, 6 minutes 45 seconds per mile. Okay, moving on to our next one. What we have to do in this one, it says here are 4 lines on the coordinate grid. Write the equations for lines A, B, C, D. So we're going to write them right here. So when we are working with lines, we have 3 different choices to write. So we could have one example be x equals. That means it's going to cross our x-axis. So our line has to go vertically. So it has to go up and down. Another option would be y equals, and that means it's going to cross the y-axis. And so it has to be horizontal. So it's going to be y equals. And lastly, it could be y equals blank x plus blank. This is what this equation is going to look like is a diagonal. So we're on this one. This would be our slope. So what's our vertical distance over our horizontal? And this would be our y-intercept. This is where it crosses the y-axis. So in this case, so we're looking at A. A is a diagonal. So our equation is going to look like this. So I want to write that in y equals blank x plus blank. So the first thing that we need to do is my easiest thing is find where it crosses the y-axis. So here's our line, and here's our y-axis. And what I'm going to do is I'm going to highlight my y-axis and my x-axis. Just to kind of keep everything straight. So line A crosses right here. So that crosses at, I'm going to count up, so 1, 2, 3. So it crosses at 3. So that's where we're going to put our back number. That's where it crosses our y-axis. That's our y-intercept. Then what we're going to do is I want to find the slope. Our slope is going downhill, so it has to be negative. So one more thing to think about is let's make Mr. Slope Guy. If our lines are going uphill, it's a positive slope. If our lines are, if they're diagonal, it's going downhill. They're a negative slope. If they're vertical, they're undefined. That's what that U stands for. And if they are flat, it's 0 slope. So we have Mr. Slope Guy. So this line A, is going downhill, so it's negative, so I put a negative sign. And so what I'm going to do is I'm going to find on the grid line where it intersects exactly at a grid point. So I want to use this point, follow it up until it hits at a grid point right there. So I'm going to count up. Each line represents a scale of 1. So we're going to 1, 2, and we're going to go left, 1, 2, 3. So our slope will be 2, a vertical distance of 2, and a horizontal distance of 3. So I would write that vertical distance of 2, horizontal distance of 3. Moving on to B. Line B is another diagonal, so it's going to be very similar. Y equals something x, and so we're going to fill in this and this. So this one, we're going to find it lands at our y-axis right there, which is from here it's down 1, 2, 3, 4, 5. So negative 5. So I'm going to write minus 5. Now we got to find our slope. So I want to use this point, and I want to follow that all the way up to this point. There's a dot actually there already for us. So we're up 1, 2, 3 over 1. So vertical distance of 3, horizontal distance of 1, so 3 over 1. And our line is going uphill, so it's a positive. So if you wanted to keep it as y equals 3 over 1x minus 5, or you can write it as y equals 3x minus 5. Either one of those would be right. So that's B. Moving on to C. It is a vertical line. It's crossing our y-axis vertical. Fine. It has to be x equals. So I'm going to write x equals. Where does it cross our x-axis? So it's 1, 2, 3, 4, 5, 6, 7. Crosses at 7. So x equals 7. And then line D. Line D is a horizontal line, so it's going to look like this. Y equals a number. Y equals, where does it cross? Here's 0, 0, it's down 1, 2, so negative 2. I'm going to stop right there because I have students coming in. Okay, number 4. Number 4 says draw the following lines and then write the equation for each. So on this one, they're giving you a slope and what the y-intercept is for each one of these. So if we are going to be thinking about notes on these first, so what slope is? Slope is the vertical distance over horizontal distance. So I'm going to zoom in a little bit. And what that means is you're going to take your y's and you're going to subtract them. And you're going to take your x's and you're going to subtract them. You're going to put them over each other like that. Y's over x's. The y-intercept, the next thing, the y-intercept is where the line crosses the y-axis. So those are the two important things you really need to know in making lines.
You write it down there.
So number 4, I'm going to zoom out. What we're going to have to do. First one, A says has a slope of 0, so we know it's a flat line. So once again, earlier we showed you the Mr. Slope guy. I'm going to write it over here. So if our line is positive, it's a diagonal line going uphill. If our line is going downhill, it's a negative slope. If it's straight up and down, it's undefined. If it is flat, it's 0. So if our slope in in letter A is 0, our line should look flat. It's going to cross our y-axis. It says our y-intercept is 5. So it means it's going to cross our y-axis at positive 5. So here's our origin, and it's going to cross at 5. So up 5. 1, 2, 3, 4, 5. It's going to cross this line at that point. So what that means, we are going to be, it has to be a horizontal line going through at positive 5. So we take our line is going to look just like that, horizontal line. And I'm going to label this one A. So on the test, you're going to be asked to do the same thing, but we're asking you to label each one. Slope, if the slope is 2, and a y-intercept is -1. So let's talk about our slope. So it's vertical distance over our horizontal distance. Vertical distance would be 2, horizontal 1. So it's 2 over 1. So if they're telling us our y-intercept is -1. It means it's going to cross the y-axis at -1. So I'm going to put a dot right at -1. So here's our origin, down 1. Now from that point, we're going to look at our slope. It's 2 over 1. So, and it's a positive slope. Positive slope, we look at Mr. Slope guy, has to go uphill. So if I'm going to do that, I'm going to go up 2, 1, 2, and to the right 1. Up 2 to the right 1. I'm going to keep doing that, up 2 to the right 1. Or you can go down 2 and left 1. Just as long as our line is going uphill from left to right. So I made dots in every possible spot. And I want to make my line. And I want to label this B. So we found our y-intercept, we found our slope. Okay, this one, C, has a negative 2. So that should tell us it's going to be negative 2 over 1. So vertical vertical distance over our horizontal distance, negative 2 over 1, and our y-intercept means it's going to cross at positive 1. So if we do that, our first step we need to do is find our y-intercept. It's going to cross at positive 1. It's going to go right here, under that. Now it's a negative slope, 2 over 1. Negative 2 over 1. So what I'm going to do, our line is going to be going downhill. So this time I'm going to go down 2 and to the right 1. Down 2 to the right 1. I'm going to keep doing that pattern, down 2 to the right 1. Or I can go back to where I started with our y-intercept of 1. And I'll follow my slope. I'm going to go up 2 and left 1. Just as long as our line is going downhill from left to right. So we have our line. You don't have to make every dot like I did. Just as long as you say 3 dots, you can tell which way the line's going, that'll be good enough. So once again, everything starts from our y-intercept. And I'm going to label that one C. I'll label it up here, C. And our last line, this time our slope is negative 1 over 2. So our vertical is negative 1, our horizontal is vertical is negative 1, our horizontal is 2. And our y-intercept is negative 1. So our first y-intercept, we're going to put our dot at negative 1. That's our beginning point. So at negative 1, there's already a dot there. That's okay. We're going to use that same one. But our slope was negative 1 over 2. So that means our line has to be going downhill overall. So if our slope is negative 1 over 2, so it's down 1 and to the right 2. Down 1 to the right 2. I'm going to follow that same pattern. Down 1 to the right 2. Then I'm going to go up 1 and to the left 2. Up 1 to the left 2. And I have enough points to make our lines. And we have our line, and I'll label that D. Okay, moving on to the next section, number 5. So in this one, it says we're going to sketch the graph of the following equations. And what we need to know on these types of problems, we have 3 different types that we can have. So whenever we have a line that is horizontal, it's going to be vertical. It has to be up and down. Or it can be y equals if it's going to be horizontal, left and right. Or if it's a diagonal, it's going to be y equals blank x plus blank. Those are your 3 types, where this first blank will be your slope, where our second blank will be your y-intercept, where it crosses our y-axis. So once again, I'll make Mr. Slope guy. If it's going uphill, it's positive. If it's going downhill, it's negative. If it's straight up and down, it's undefined. If it's flattened, it's 0. Okay, so looking at y equals 3. It means it has to cross our y-axis at 3. So I'm going to put a dot at 3. 1, 2, 3. It's crossing our y-axis. When we set our lines, have to go horizontal across them if it's y equals a number. So here's our first line. We're going to scoot across. In this one, we have our slope. We have our y-intercept. Make sure you include, in this case, you look at the sign in front, it's negative. So what they're telling us, in this case, our y-intercept is negative 1. So I'm going to put a dot. Here's my origin, 0, 0. It's going to be down 1. From that point, we're going to use our slope. It's a positive slope, so our line's going to go uphill. So I'm going to go up 1 and to the right 4. 1, 2, 3, 4. And I can't go, I'll run out our dot would be somewhere out here if I kept it going. Instead, I want to go down 1 and to the left 4. 1, 2, 3, 4. That's enough points. Make a line. Moving on to the third one, x equals 5. In this one, if it's x equals, it has to be a line that goes vertically, up and down. So they're saying it has to cross the x-axis at 5. Here's our x-axis, x and our y. Crosses at 5. So we go across 1, 2, 3, 4, 5, and it's going to go vertically up and down right here.
Oh, I'm sorry. Wow.
Moving on to our next problem. Y equals negative 3x minus 3. So this negative 3 is going to be our y-intercept. That's where it's going to cross the y-axis. So I'm going to put that in right away. So here's our origin. Being it's negative, it's going to be down 3. 1, 2, 3. Then we're going to look at our slope of negative 3. So what that's going to look like, all whole numbers have a 1 underneath. So our slope will equal negative 3 over 1. So if I did that from this point, negative 3, I'm going to go down 3, 1, 2, 3, into the right 1. Because it has to be going downhill, being it's negative. Now I'm out of room, so I'm going to go back to my starting point at negative 3. So I'm going to go up 3 this time. 1, 2, 3, and left 1. Just as long as our line overall is going downhill. 1, 2, 3, over 1. 1, 2, 3, over 1. So I'm going to put my line in. And there is our line. Okay, moving on to our next question. This is quite lengthy review, but it's going to help you tremendously on the test. So our next question, 6A through D. What we're going to have to do, they're giving us different scenarios, and what we have to find out is we have to write an equation for each one of these. So in this, we have to look at important things to consider. So it says in order to join a dancing club, there's a $30 startup fee. So just to even just join, it costs $30. Then they charge an extra $4 per month. So it says write an equation in slope-intercept form that models this situation. So in this case, what we're going to have to do, let's let x equal the number of months, and y will equal total cost. So what we're going to do is our total cost, so our first startup fee, our total cost will equal $30 startup fee plus it charges $4 per month. So that could be an equation. Or if you wanted to write it, y equals 4x plus 30, that's all the same. Either one of those would be correct. Or if you wanted to write 4x plus 30 equals y, all of that's the same. Number 7, B, 6B. It says in order to join an online learning community, there's a $20 startup fee and a $5 monthly fee. Write an equation, slope-intercept form that models the situation. So this one, I'm going to write x is months, the number of months, y is total cost. total cost equals $5 per month, so 5x, $5 times the number of months, plus the $20. That would be our equation. Moving on to 6c. So suppose that a bike rents for $4 plus $1.50 per hour. So this is like your startup fee. So let's let x equal number of hours and y is total cost. So if we're writing this out, our total cost would be how much per hour? $1.50 an hour. So we write that as $1.50 times x. And then we have this automatic $4 charge, plus 4. And our last one in this section, D, in order to become a member of my fan club, there's a $40 sign-up fee and a $2 monthly fee. So this one, we're going to let x equal months, y equals total cost again. So write the equation in the slope-intercept form that models the situation. So total cost of y equals, we're getting charged $2 a month, so 2 times our x, the number of months, but then there's this $40 sign-up fee, plus 40. And that would be our equation. Moving on to number 7. So in number 7, you are asked to select all the points that are on the graph of the line x plus 2y equals 10. And they're giving us a series of ordered pairs. So what we're going to have to do is we're going to use this equation, x plus 2y equals 10, and we're going to substitute our x and our y into each one of these equations to see if it works out. If it works out, we know that point, this ordered pair, is on that line. So if we are doing this, so I'm going to write out our equation for our first one. X plus 2y equals 10. I'm going to substitute 7 in for my x and negative 4 in for my y. So I'm going to keep going. X would be 7 plus 2. Y would be, 2 times y would be 2 times negative 4 equals 10. So we'll see if this works out. 7 stays the same. 2 times negative 4 is negative 8. 7 plus negative 8 would be negative 1. Does negative 1 equal 10? No, it does not. So we know our first one, E, does not work. So we're going to have to test each one of these out. Moving on to F, use the same equation. X plus 2y equals 10. I'm going to substitute 5 in for my x, so it's 5 plus 2 times our y of 0 equals 10. 2 times 0 is 0, so we have 5 equals 10. Nope. So letter F does not work. Zoom on a little bit. Once again, we're going to use same equation. X plus 2y equals 10. Substitute 0 in for x. In this case, we're going to substitute 5 in for my y. So it's going to be 2 times 5 equals 10. 0, 0, so 2 times 5 is 10. 10 equals 10. Yes, finally. We have one that works out. So G will be a yes.
Boy, shut up. You're not even supposed to be where you are.
Moving on to our fourth one, letter H. So we have x plus 2y equals 10. This time we're going to substitute 4 in for our x. So we 4 plus 2 times our y of 3 equals 10. Let's see if it works out. 4 stays the same. 2 times 3 is 6. 4 plus 3 is 10, so 10 equals 10. Yes, this one does work out. So H is yes. Moving on to our last two, letter I. So I'm going to use this x plus 2y equals 10.
Sorry.
Our x value is 3 plus 2 times our y value of 4 equals 10. 3 stays the same. 2 times 4 is 8. 3 plus 8 is 11. 11 does not equal 10. So letter I does not work. And our last one, J, use the same equation, x plus 2y equals 10. We're going to substitute x with negative 4. So negative 4 plus 2 times our y value of 7. 2 times 7 equals 10. So negative 4 stays the same. 2 times 7 is 14. Negative 4 plus 14, we have opposite signs. One's positive, one's negative. We subtract them, we get 10. And there's more positives than negatives. So 10 equals 10. Yes, this one works out. So for our answers, we have a no, no, yes, yes, no, yes. But you're going to be expected to show your work, just like this on the test, to prove if it worked out or not. So you're given your x and y, you're going to substitute into the equation. If it's a true statement, like in our last one here, where 10 equals 10, it's yes. If it doesn't, like in this one, where 5 does not equal 10, that's a no. All right, moving over to the next side.
Is that what we're done?
Nope. So on this one, there are some word problems that we're going to have to do here. It says it costs 50 cents to buy Miss Cumber a Coke. Now maybe this says your teacher, but this example I have from Miss Cumber. So 50 cents for every Coke that Miss Cumber buys. And it costs $5 to buy a pumpkin spice latte from Starbucks.
And that's expensive.
So you have a total of $25 to spend on a gift for her. So what we're going to do, so let's look at A and B. So our A says complete the table showing 3 ways you can spend $25 buying something for Mrs. Cumber to drink. And B says you're going to write an equation related to the number of Cokes and the number of pumpkin spice lattes you can buy. I want to start with B, coming up with our equation. So in our problem, it says it costs 50 cents to buy a Coke. We're going to let C be Coke. So what I'm going to do is I'm going to write 0.50, 50 cents. I'm going to write a C right next to it because it's number of Cokes times 50 cents. Then we're going to add plus $5, so 5 P, because that P stands for pumpkin spice lattes, and it has to equal a total of $25. That's all the money you have. So in this table, we're going to use this equation to solve our table. So if we had 10 Cokes, and we're going to use this equation, I'm going to write the work on the side here. We have to find out the number of pumpkin spice we can afford. So we have our equation, 0.50. This time we're going to write times 10, because there are 10 Cokes, plus 5p equals 25. There's our equation. 50 cents times 10 is 5. 5 plus 5p equals 25. We're going to subtract 5 to start working to get p by itself. 5's are gone on the left, so we have 5p equals 25 minus 5 is 20. We'll divide that by 5 on both sides to get p alone. P will equal 20 divided by 5 is 4. So you can buy 10 Cokes and 4 pumpkin spice lattes. Moving on to the next one. This time, they're giving us the number of pumpkin spice lattes, but we have to figure out the number of Cokes. So use the same equation that we're using down here. So it's going to be 0.50C plus 5 times, in this case we know it's 3 pumpkin spice they're going to buy. We're going to set that equal to 25 because that's all you have. 5 times 3 is 15. So I'm going to bring down the 0.50c equals 25. I'm running out of room. I want to subtract 15 from both sides. So my line over here, since I'm running out of room, the 15s are gone. So we have 0.50c equals 25 minus 15 is 10. So I'm going to divide by 0.50, 50 cents on both sides. What I do to one side, do the other. 10 divided by 0.5 would be 20. So you could buy a total of 20 Cokes. So on our chart above, you can write 20 for the number of Cokes. Okay, in our last one, they're giving us the number of Cokes, but we got to find out the number of pumpkin spice lattes. So if you bought 50 Cokes from Miss Cumber, or your teacher, so I'm going to use my equation, 50 cents times, I know my Coke value is 50. And with plus 5p equals 25. 50 cents times 50 is 25. Plus 5p equals 25. I want to get p alone, so I need to get rid of this 25 first. What determines what I get rid of first is 25 or the 5. I always want to get rid of the number furthest away from my variable, p. So I want to subtract 25 from both sides. What I do to the one, I get the other. 25s are gone on the left, so we have 5p equals 25 minus 25 is 0. We're going to divide by 5, so p will equal 0. So you can't buy any. If you bought 50 Cokes, you can't buy any pumpkin spice lattes. Next one.
Wait, number recording?
Next one, number 9.
I have a question. Are you gonna cut all this coffee out?
There's gonna be like a lot of coffee. Coffee.
Okay, on this number 9, what you're going to be doing is we have A through F to answer, all looking at this line graph. It says for the graph below, answer the following questions. So the very first thing is, what is the slope? So what I can do, there are some dots on here that already cross at an intersection point. I can pick really any of them. And what I'm going to do, I'm going to pick this one and this one. So remember, in slope, we need to find the vertical distance over a horizontal distance. So while we're doing this, we have to be very careful of. We've got to be able to identify how much each line represents for our scale. And we're going up by 20s, 20, 40, 60, 80. So each line would be worth 20, so 20, 40. So we have a vertical distance of 40. And down here, we're going by 5, so 5, 10, 15, 20. So each line represents 5, so 5, 10. So there's our slope. So we're going to write this. It's going to be y over x. So vertical distance is 40. Our horizontal distance was 10. If we went 40 divided by 10, that'd be 4. You could say 4 over 1 if you'd like. So if you divide by 10, those are gone. So they're saying, so what does the slope mean in this context? You could say it costs $4 per 1 minute. For every minute, it's going to cost you $4. You notice on this chart, it doesn't tell us what it's referring to. We just know it's on time, and that's what it costs. So keep that in the back of your mind. We're going to probably have to come up with a title, what this context could possibly be about. Letter B, what's the vertical y-intercept? So vertical intercept, or the y-intercept, is where it crosses the y-axis. So if we're looking at this, here's our y-axis. It crosses right there. And we said it goes up by 20. So our y-intercept, our vertical intercept, either one is the same thing. Our y-intercept equals 20.
Here.
Oh, class is over.
All right, we left off at number 9, letter B. I didn't answer the total question yet. It says, what's the vertical y-intercept? So that means where does it cross our y-axis? So in this grid, we have the amount of time in minutes going on our y-axis, our x-axis, and our y-axis is the total cost. So where it crosses our y-axis is called the vertical intercept or the y-intercept, and it happens right there. I circled it, and we've said that our scale factor, our scale, is going up by 20. So 20, 40, 60, 80. Always confirm what your scale is. It crosses our y-intercept at 20. So I put y-intercept equals 20. And then they're asking, what does the y-intercept mean in this situation? And you could say, the startup cost equals $20. Or if you don't want to say startup, you could say the sign-up fee. It's all the same. So right away, they charge you $20 before it even begins. That's what that means. Otherwise, if they didn't charge you, if they're just charging you per month without a setup fee, it would start at 0. But in this case, it doesn't. Okay, the next part they're asking for is part C. What's the equation for this line? So we're going to have y equals blank x plus blank. The reason why we're going to have an equation that looks like this because it's diagonal. Our line is going uphill, so it's positive. So that's our slope's going to be positive. So this will be our slope, and this will be our y-intercept. So basically what we found out in both A and B, we found our slope in A to be 4 over 1. So you could put 4 over 1 if you wanted here, or just 4, so 4x. And we found out in B, our y-intercept was 20, so this will be plus 20. There's our two equations. I'm sorry, there's our equation for that line. And D, it's asking us to actually create a context to what this graph could possibly be representing. So we have startup cost of 20, and they're charging $4 per minute. So what possibly could they be charging if I had, so I have to come up with a scenario. So this is what I'm going to say. So it costs $20 startup fee to get a massage. Plus $4 for every minute.
$4 every.
Yep, $4 for every minute. I don't know if that's reasonable or not. So every minute you get a massage. So what they're saying, in this case, I guess it would be pretty expensive massage. At 30 minutes, a half hour, you would be paying $140. That's pretty expensive. So maybe this scenario would not be the best. A massage. Can anybody think of another scenario? Startup cost, maybe in minutes. I'm not sure, but that's what I would recommend. So startup cost of 20 and then plus $4 for every minute. Oh, plus $4 for every minute. Make sure you include the 4. $4 for every minute you get a massage. Okay, moving on to E. Is there a proportional relationship between the time and cost? So remember in order to be proportional in our graph, our line has to go through at your 0, 0, and it does not. So in this case, you could say no, because the line does not go through the origin, which is 0, 0. In our very last question on the test, it says draw a line parallel to the line graphed that goes through point 060. What's the initial fee and the cost per minute for this line? So what they're looking for is we need to draw a line, a parallel line first. Then they want to know what's our y-intercept and what's our slope. Essentially what they're asking for. So our line goes through at 060. So I'm going to make a dot at 060. So over 0, up 60. Remember, we're going up by 20. So 20, 40, 60. So our line's going to go right here. And it has to be the same. If you remember, parallel lines have to have the same exact slope. So if we did that, it's over 2 and up 2. So over 2, up 2. Over 2, up 2. Over 2, up 2. So what I'm going to do is just draw my line. So they're parallel, they'll never intersect. And they're asking in part F, what is the initial fee? The initial fee, so where does it cross the y-axis? 60. So you can say initial fee equals $60. And then they're asking, and what's the cost per minute? It's going to be the same exact slope as the line that was given to us. If you look at our scale on the bottom, we're going across each one of these lines is 5, 10, 15, 20. So if this is the case, we're going from here to there. So we're going up 5, 10, or across. And then each of these is going up by 20. So we're going 10, 20. So vertical distance is 40. So 40 over 10. So 40 over 10, which we can reduce. We divide by 10, we get 4 over 1. So it costs $4 per minute. Costs $4 per minute. So that concludes our review. So I know the review is pretty broken up with interruptions, but we'll try to splice it all in the best I can.